Water and ethanol form what's known as an azeotrope. This occurs when a mixture of liquids has a higher or lower boiling point than each of the individual components. In the case of ethanol, a mixture of 95% ethanol to water boils at a lower temperature than pure ethanol. So, at a concentration of 95%, there's really nothing you can do by distillation that can concentrate the ethanol further. And luckily, there are two other major methods that can be used to get to 100%. Another method is to add another solvent to the mixture, which forms an azeotrope with water that's at a lower temperature than the ethanol water one. This way, the other solvent and the water can be boiled off azeotropically, and it will leave behind pure ethanol. The second method is the method I'm going to show, and it's the one that's easiest to do at home. It's pretty simple, and what we'll just be doing is adding a drying agent to the ethanol that soaks up the water. In a future video, I'll show the distillation and how to get 95% ethanol from any percentage lower, but for this video, I'm going to start at 95%. Luckily for me, my local pharmacy simply just sells 95% ethanol, so it's a pretty simple starting point for me. So now the question of why anyone would even want 100% ethanol. I personally need it because there's some reactions that I would like to run where I need to use ethanol, but I can't have any water present. Another major use that I won't need it for, but others may, is to add it to gasoline. Anyway, now to get started with the preparation. The first thing I'll do is use my hydrometer to verify that the ethanol is actually at 95%. So first it's placed into a grad cylinder, and then I pour my ethanol in until it floats. The hydrometer functions based on the principle of buoyancy. Water is more dense than ethanol, so the more water that's present, the higher the density of the mixture and the more the hydrometer will be pushed out of the liquid. All of this is to say that the concentration of ethanol is directly related to its density, and this tool lets us find it out pretty easily. So we can see here that it's actually floating a bit above 95%, which makes sense because the azeotrope is actually 95.6%. I should also note that my hydrometer is specifically an alcohol hydrometer, so instead of density, it reports alcohol concentration, but you could also just use a regular hydrometer which shows densities and correlate it to a table online. Just as a quick aside, you can see when it's placed into just water that it's pushed much higher. So now that we see the ethanol is above 95%, we see we can dry it without using too much drying agent. It's first added to a large container. I have a stir bar at the bottom, but it's kind of pointless because once enough drying agent is added, there really won't be much stirring happening. And once all the ethanol is added, we can start adding our drying agent. For my drying agent, I use what's known as molecular sieves. These little sieves have very small pores in them which can absorb water, but the pores are too small to allow any other larger molecules to enter. So this means that the small water molecules can find their way in and bind to these little beads, but the ethanol is too big to do this and will be left untouched. I should note that I use 3A molecular sieves because there are different sieve sizes that will absorb ethanol. I like to use molecular sieves because they're pretty easy to regenerate afterwards by simply letting the ethanol evaporate and then driving off the water using an oven. However, there are other drying agents that can be used. Some people use other drying agents like magnesium sulfate or copper sulfate, but I really much prefer the molecular sieves. Once the sieves are added, the container should be sealed and allowed to sit overnight. I let it sit for several hours and then tested the concentration, and unfortunately, it wasn't really that close to 100. The process of picking up water can be a little bit slow though, especially if no stirring is happening. Also, my sieves weren't freshly dried, so they might not be working optimally. However, because they can be pretty easily regenerated, I opted to do the overkill route. So I added about 120 grams more. Because the molecular sieves can be regenerated, there really isn't a downside in terms of molecular sieve loss by adding more. However, when the ethanol is decanted later, a lot is going to stick to the sieves, and the more that you use, the more loss will occur. The solution is cloudy because of little bits of dust of the molecular sieves, but this really isn't an issue for now. When allowed to sit overnight, you can see all the dust settle to the bottom, and we're left with a crystal clear solution. So now we pour it in, and we can see that it's pretty much 100%. So the next step is to separate the ethanol from the sieves, and to do this we're just going to use a coffee filter. All of the wet sieves are dumped into the coffee filter to hope that some of the ethanol will drip through. You'll notice that a lot of the dust from the sieves actually makes it through. And the amount of dust that you get with your sieves will depend on the source that you buy it from. I bought mine from a pretty cheap source and I think it had more dust than usual. Anyway, at this point you have two real options. You can let all the dust settle to the bottom and decant and filter again, and you should be left with a pretty clear solution, or you can distill. Depending on your ethanol source, you might want to distill it. For example, mine was bought from the store and it has a lot of denaturing agents that can actually be easily removed by distillation. So for this reason, I opted to distill. Note that the final solution of anhydrous ethanol should be stored over sieves, so if your only reason to distill is to get rid of the dust, it might not be worth your time. I then set up a fractional distillation, but it was probably totally unnecessary and a simple one would more than suffice. In my case, none of the denaturing agents are volatile, so they should all be left behind in the flask. So this is what the upper part of the distillation looked like prior to wrapping it with aluminum foil. The column was then wrapped with aluminum foil to insulate it and help the ethanol pass over. You can see that the receiving flask is packed with sieves to keep the ethanol that comes over dry. Eventually all the ethanol comes over and it should be pretty much 100%. At the bottom of the distillation flask, we're left with a mixture of the denaturing agents and the molecular sieve powder. So to test out the ethanol concentration, we again pull out our trusty hydrometer. So we can see here that the hydrometer floats very nicely at the 100% mark. So now we have some nice 100% ethanol and we transfer it to an appropriate container. In theory, I could have just used the same bottle that the ethanol came in and changed the labels, and I'm honestly not sure why I didn't. Anyway, once the ethanol is added, then I dump in a bunch of sieves just to keep it dry. It's then capped, sealed off, and labeled, and we're left with our nice 100% ethanol. One thing to note is that the sieve dust really shouldn't be a problem as long as you don't shake the bottle a lot before you use it. If you remain gentle when you pour it, all of the dust should remain near the bottom. Anyway, that's it for now, and remember to store the ethanol somewhere safe.